Hello and welcome. Today, we'll explore the main types of machine learning algorithms, how computers learn from data and improve performance, and where these algorithms are applied. Machine learning is a branch of artificial intelligence. It allows computers to learn patterns from data. This process enables them to make predictions or decisions. Unlike traditional programming, it doesn't require explicit instructions for every task. Understanding machine learning is crucial for modern AI systems. Machine learning algorithms are categorized based on their learning approach. The main types include supervised, unsupervised, and reinforcement learning. Each type has unique methods and applications. Understanding these categories helps explain AI operations in various fields. Let's delve into each type to see how they function. This is a main callout for this scene. It brings into focus the core idea being discussed. Supervised learning uses labeled data for training. The algorithm learns from examples where the correct output is known. It's widely used for tasks like classification and regression. This approach is effective, but requires large labeled datasets. Popular algorithms include decision trees and neural networks. Unsupervised learning works with unlabeled data. It identifies patterns or structures without predefined answers. Common tasks include clustering and association analysis. This approach is useful for exploratory data analysis. However, interpreting results can be challenging without labels. Reinforcement learning involves learning through interaction and feedback. An agent learns by receiving rewards or penalties for actions. This approach is used in robotics and game playing. It requires significant training time and resources. Famous examples include AI systems like AlphaGo. Semi-supervised learning combines labeled and unlabeled data. It's useful when labeled data is limited, but unlabeled data is abundant. This approach improves learning accuracy in fields like image recognition. It bridges the gap between supervised and unsupervised learning. Semi-supervised learning is a practical solution in many scenarios. Deep learning uses artificial neural networks with many layers. It models patterns similar to human brain processing. This method excels in tasks like image and speech recognition. Deep learning powers technologies like virtual assistants. It requires large datasets and computational power. Each machine learning type has strengths and limitations. Supervised learning is accurate with labeled data, but costly. Unsupervised learning reveals hidden patterns but can be hard to interpret. Reinforcement learning is effective, but resource-intensive. Choosing the right approach depends on the problem and data availability. Oracles provide correct answers that guide learning. In supervised learning, they validate the algorithm's predictions. Oracles are crucial for training accurate models. They ensure the results are meaningful and reliable. Without them, models might not learn effectively. Labeled data includes input information with correct output labels. It's essential for training many machine learning models. Quality and quantity of labeled data affect model performance. Creating labeled datasets can be costly and time-consuming. However, they are vital for supervised learning accuracy. Obtaining labeled data is often difficult and expensive. It requires human experts for accurate classification. Errors or biases in labels can mislead models. Researchers use semi-supervised learning to mitigate these challenges. Combining labeled and unlabeled data enhances learning. In many scenarios, perfect solutions aren't necessary. Systems often aim for good or acceptable results. For example, recommendation systems suggest useful products. Route planning considers practical routes over shortest paths. Labeled data guides these systems to produce useful outcomes. Unsupervised learning doesn't rely on labeled data. It identifies patterns without predefined answers. While insightful, evaluating these patterns can be challenging. Labeled datasets remain essential for practical applications. They ensure the discovered patterns are meaningful. Understanding these types is key to applying AI effectively. Any questions or concerns? Send a WhatsApp message to 0748 and our team will gladly assist. Thank you, and see you next time.